Right. Yeah.
I think yeah, there's everybody here now, right? All right. So guys, sorry about that little technical difficulties. That has happened sometimes, but right, cool. So everybody hearing me, we good. Let me start back over the question because I was talking up a storm and nobody wasn't hearing me. So let's start, right? We're looking at the 2016 paper, right? We're just finishing it off. This is the module 3 section of the 2016 paper we're looking at, right? The first question, this question 5, and we're getting straight into it. No wasting any time because I don't waste a bit of time, right? So we're looking at it here. We have the saying part A. So this is question 5, part A, right? The saying that a bus has 13 seats for passengers, right? 8 passengers board the bus before it left the terminal. Determine, yes, the live will be saved for viewing for everybody who wants to view it, right? It will be saved. Tia. So yeah, let's continue with the question. Determine the number of possible seating arrangements of the passengers who boarded the bus at the terminal. So we have 13 seats and you have 8 passengers. And when from the time we see this thing, this is really key in the question. Arrangements should, what should come to mind already is permutations. And we know permutations is the number of ways of arranging n distinct objects, right? And we also have to know how to arrange n or r out of n distinct objects as well, where permutations are concerned. So this question is 2 marks. It's pretty straightforward. What you have to do is take the 8 persons and they want to find the number of ways of arranging those 8 persons in the 13 spaces, or rather, yeah, in the 13 spaces, right? So the number of different ways. So basically, right, the formula for arranging R out and distinct objects is what you need to use for this particular question. So this is what you would basically do. You use NPR, right? N in this case is 13 because you have 13 seats, but you want to arrange the 8 persons that coming into the bus into these 13 seats, right? And you want to find the number of ways of arranging it. When we plug this into our calculator, right, you just plug it in NPR, and I believe everybody should know how to find, right, the permutations, that NPR symbol on a calculator, right? If you don't know, you need to find out, right? When you plug it into a calculator, 13P8, this is what you would get, this very large number. That looking like 51 million something. So it's a lot of different combinations there, right? Good afternoon to everyone. Somebody wants me to zoom in a little bit more to the question. All right, just a second. Let me see how this will work. Select. Right. I hope this works. Tell me if this is better. Is this better? Is this better on the Zoom? Are you seeing the question a bit better? I hope you all are. So that's the first question. You collect 2 marks there, right? So it's about arranging those the 8 persons into these 13 seats, right? The number of different arrangements. So that's basically that. Everybody, I hope everybody understood it, right? Another way of doing it, right, really quickly, you can also use the box method. I don't know if you are familiar with this, but you could use the box method, and what you would do is take the 8 persons, right? Because it's 8 persons you want to arrange. 1, 2, 3, 4, 5, 6, 7, 8. And it's 13 spaces. So we take 13, right? You put the first person in one of the 13 seats. Then you take the next person, the next one, so that would be the 7th person, right? Or 1 out of the remaining 7, and put them in the 12th seat, right? And so on. And this would also too give you the same answer. You could just check it out. Check if this product here will give you the same answer, right? And you're going down. This product as well should give you the same answer, right? So that's another way of thinking about it. You have 8 persons to arrange, and it's in 13 seats. So you put the first of the 8 in one of the 13 seats. Then you put the next, the remaining 7, one of the 7 into the remaining 12, and so you go along and you just decrease up to, right, and you reach 6 here, right? And that should also to give you the answer. It's blurry for you. Some people seeing it better, but when the recording comes up, you should be able to see it good. Just don't know why some people not seeing. You're not seeing what exactly the writing, my writing, or the text itself. If you're not seeing, most likely when the video is uploaded again, or when it's uploaded onto YouTube, you should be able to see it properly, right? But moving forward swiftly, right? So that's the solution there for that question. And if you're not seeing it, let me try. I wonder. Let me try going back. This is the question as well here, right? I don't know if everybody's seeing it much better. Could be the internet. Are you seeing this particular question properly? I hope everybody is seeing it. Good afternoon to everybody coming into the live, right? So I hope everybody's seeing the question. So this was the first question we did with the 13 seats, right, on a bus, and you have 8 passengers boarding the bus before it left the terminal, and they want us to determine the number of possible seating arrangements for the passengers who boarded the bus. And we said the solution for this was 13p8, right? So now let's move on. Right, let's move on to the second question. We're going to look at the second question, the second part of part A, right? So the second part is saying at the first stop, no passengers will get off the bus, but there are 8 other persons waiting to board the same bus. Among those waiting are 3 friends who are still together. Determine the number of possible groups of 5, right? Determine the number of possible groups of 5 of the waiting passengers that can join the bus. So remember, we have 8 persons already in the bus, right? But when the bus makes its first stop, no passengers come out. So it still just have 5 persons because 13 seats we have, right? And 13 minus 8 would leave 5, right? So no persons came out of the bus, right, containing 8 persons. So you just have 5 spaces. So what they're saying is among those waiting, they want us to find out, or they want us to determine the number of possible groups of 5, right, of the waiting passengers. How much waiting passengers we have? There are 8 other persons waiting. So we have to choose 5 persons out of the 8, right, to join the bus, right, because it's only 5 spaces remaining. So what they want us to determine is the number of possible groups of 5 of the waiting passengers. We have 8 waiting passengers, right, that can join the bus. But it have a little condition on it. They say among those waiting, 3 friends who must sit together, right? That's the key to this question. So what we could do here, this is about choices. You have 8 persons waiting, and we have 5, right? We could choose out of the 8. So you have, let me just go to the next page, right? I want to go to the next page really quickly, right? So this is the smaller version of the question, right? I hope everybody, you might not see it. Yes, I am doing part 2 right now, right? So you may not see it well, but let's just move on really quickly, right? So this was the solution we had here, right? So the first thing, and this was the other stuff, right? What we can do here, and I'm just going to make the screen a little bit smaller, or rather the question a little bit smaller, just for a second here, right? What we need to do, the first thing we need to do is find, right, the group with the 3 friends, right? We need to get out of the 8 persons waiting. We know we have 8 waiting, right? We have 8 on the bus, 8 waiting, right? Because we have 8 waiting, we just only have 5 spaces remaining on the bus. So we need to take 5 out of the 8 persons waiting. But what they say in the question is, they said that out of those waiting, 3 friends must sit together. So let's look at the instance where the 3 friends sit together. If the 3 friends sit together, then we could just choose. If we choose those 3 friends, they would sit in the bus, and then you have just 2 persons to choose out of the remaining 5 persons. So this is what I'm saying will happen here in the case where you choose the 3 friends who must sit together. These are the 3 friends, you know, in school that always with each other. You can't separate them. That is these 3 friends. They say they must go one with the other, right? So basically, this is what will happen here. And I need to go back a little bit, right? I need to go back because some of my stuff here kind of not aligning, right? So this is what will happen here, right? You will have the group with 3 friends would be you choose the 3 friends. So that is 3 choose 3. That's what you have. And then you multiply that by 5 choose 2. Because when you choose the 3 friends, right, it only have one way of choosing those 3 friends, right? This 3 choose 3 would give you what is the same as 1, right? And then you multiply that by 5 choose 2, because remember, you have to now choose two more persons to make the total of 5 to fit onto the bus, right? To fill the bus. So you need to now choose two remaining persons out of the 5 remaining outside, right? Who outside waiting on the bus. So that is what we'll get there. And then the second thing that could happen is we could forget about the 3 friends, right? And we could just choose the 5 remaining persons on the outside. Remember, you have this 8 persons on the outside waiting to come onto the bus. You have the 3 friends, and you have the 5, you could say 5 random persons, right? They don't need each other to come onto the bus, right? 5 other persons. So this is the case here. The first case is where the 3 friends chosen, it only have one way of doing that, and you multiply it by the remaining 2. You choose 2 out of the 5 here. That's what happened there. And that's basically that. And then the second way is without the friends, right? What will happen here is basically this. You choose 5 out of the 5 persons, the 5 remaining persons, right? So remember, this is the split here. Your 3 friends and the 5 here. So if we don't choose the 3 friends, we could just choose the remaining 5 persons to go on the bus and fill it up, right? And that's basically it. All we do now is make the calculation for this and this and add it up, and that would be the number of choices there. So this is what you'll get. You'll get 10 for here and 1 here, and then you just find the total, right? 10 plus 1 is 11. So this is what you have here, right? This is your total, and in the end, you just tie it up and say that the number of possible groups of 5, right, of the waiting passengers that can join the bus is 11. That is the number of possible groups of 5. So you have 11 possible groups of 5 that could come onto the bus and fill it up. Because remember, in the end, so I want you all to make sure that you're understanding the story at the end of the day too, right? You had 8 persons on the bus already, 8 on the outside waiting to come onto the bus, but you can't have the entire 8 coming onto the bus, right? Because it only has 5 more spaces. The capacity of the bus is 13 persons, right? So yeah, 11 is the answer, right? I hope everybody understanding, everybody following so far. Why is in the chat if everybody okay? Right? So saying, yeah. So I hope everybody's understanding thus far, right? If anybody have any questions, feel free to say so in the chat. We're moving forward now, right? So let's look at the next question. What does the next question have in store? Everybody seeing this question clearly? All right, cool. Kioni in the dance. Nice to see you, Kioni. We have to look at this next question here. So this is part B. Part B, let's look at it. Everybody seeing this question here clearly? Just want to make sure everybody's seeing it clearly. We have Gavin and his best friend Alexander are 2 of the 5 specialist batsmen at a school. So we have Gavin and his best friend Alexander. They are 2 of 5 specialist batsmen at a school's cricket team. They say in here, given that the specialist batsman must bat before the non-specialist batsman, and all 5 specialist batsmen may bat in any order, what is the probability? So they're asking probability that Gavin and Alexander are the opening pair for a given match. So from the time I see in probability, what should come to your mind? Yeah, I know somebody was saying that they can't see clearly. I think what I believe everybody is seeing clearly now. This one, I try to size it as big as I can, right? So hopefully everybody's seeing it. But when the video uploads, right, onto YouTube, you normally see it good. I checked it over, and sometimes you see it pretty good. You could try to zoom in onto the video as well if you have that capability, right? But we're moving forward, right? So probability. This question involves probability. That is the key thing here. You're seeing that here? Probability. And probability is the number of favorable outcomes over the total number of possible outcomes, right? So, or the number of desired outcomes, right? So in this case, the desired outcome is they want to find out Gavin and Alexander opening on a given match. So what I like to do first is, and this question, if you look at it, it is with regards to, it's regards to permutation. Gavin and his best friend are 2 of 5 specialist batsmen in the school. Given that specialist batsman must, right, bat before the non-specialist, and that all 5 specialist batsmen may bat in any order, right? So the order is what kind of leading me to think it's permutations here, right? What is the probability? And then they say that Gavin and Alexander are the opening pair for a given match. So it's 5 batsmen, right? They're the 5 specialist batsmen. So they want to try to find out the probability that Gavin and Alexander open for a given match. So let's look at first, I'm thinking probability. For sure, we know it's probability. And it's probability with regards to permutations here, because it's the order of the 5 specialist batsmen, right? So that's what we're looking at here. So my first thing is to actually find, remember we say probability is the number of desired outcomes over the total number of outcomes. So the first thing I want to do is find the total number of outcomes. The total number of outcomes would be the total number of ways of arranging the 5 individuals. So this is what I'm going to put down here first, right? The number of ways of arranging the 5 specialist batsmen. You have 5 persons, right? Each person is considered to be different, right? When you look at permutations. So we use 5 factorial, right? Or n factorial is normally the way we use to arrange n distinct objects, right? So all 5 persons are different. So 5 factorial, that would be a total number of ways of arranging the 5 specialist batsmen. But we need to find out what is the desired, right, outcome, right? And that would be for Alexander and Gavin to be the opening pair of batsmen. So that's the next thing we need to do. So we're breaking up the question, right, as small as we can, and then we will put it together in the probability formula. So the next thing we do is the number of ways of arranging 5 specialist batsmen with Gavin, and I just represent Gavin as G and Alexander as A, right? Opening. So this is what we do. We put down 5 boxes, right? And key thing with the 5 boxes here that you would notice, right? We put either inside here. What I did was I put 2 inside here. You probably want to know why I put 2 there, right? We put 2 there because you could put either Alexander inside there or Gavin, right? And then once you put Alexander or Gavin there, you then put whoever remaining in the second space, because remember they had to be the opening pair of batsmen. So therefore we could put Alexander here, A here first, right? And if we put A in the first space, then we have to put G here, right? He's the remaining person. Or we could put G first and then A here, right? So that's your 2 possible ways. So you have 2, right? You could put it 1 out of the 2 inside there. So that's why we put 2 there. And then you put the 1 remaining person, right? Whoever it is remaining between the 2 friends, right? The 2 best friends, Alexander and Gavin. And then the remaining persons, we put the remaining, any one of the remaining 3 here. So that's why we have 3 here. Any one of the remaining 2 persons, we put them here, right? And the last person, we put him here, right? And that's basically it. What we do now, once we identify what we put inside the boxes, we just multiply this out, right? Clearly, too, you could see that this is actually just 2 factorial by 3 factorial as well, right? 2 by 1, 3 by 2 by 1, right? So you could see that as well, and this will be a solution there for that, 12. So the next thing we do, we not finish here, we find the number of favorable outcomes, which would be this. This is your number of favorable outcomes, and this is the total number of outcomes. So now we put everything together into our probability formula. So this is where things get really exciting, you know, because you're coming to getting the answer, right? So we say the probability that Gavin and Alexander open, because that's really what they ask us, right? Look, just make sure always when you're doing a question, try to understand or make sure you have at the top of your mind what it is the question is asking. So that is always at the back of your mind or at the top of your mind, so that you don't stray and you remember, well, what it is you're going towards, what it is you're working towards. So we have, what is the probability that Gavin and Alexander are the opening pair for a given match, right? So I just put Gavin and Alexander open, right? In other words, they are the opening pair. And what I do is I would put this, the 12 divided by the 5 factorial, right? So this is what we would get here, right? And you put that, you plug this into your calculator, and this is what you get, 0.1, and that's your probability there, right? Somebody saying they're still not seeing, a lot of people not seeing, they're saying it's blurry. I don't know if that's an internet issue or what, but hopefully when the video uploads, right, and you'll look at it again, hopefully you see it clearly, right? But we're moving on swiftly. If you want, you could probably try to start over the stream, right? Reload it. Hopefully that helps. Yeah, or try changing the quality of the video, right? Aaron is saying to change the quality of the video. Hopefully that helps as well, right? Guys, also to remember to like, right, share the stream, right? Don't be afraid to do that, right? Anybody have any questions, comments? Why isn't the chat if everybody okay so far and following? We're moving along swiftly because we still have a lot of questions to do. So let's move on. So this is your answer here, right? 0.1 or 1 and 10, right? That is your answer there. This is not standard 5, Shakim. This is form 6, unit 2, upper 6 to be exact. So if you're looking at this, you might be really confused. Don't do it, right? So let's move on. Let's move forward to the next question. What does the next question have in store for us? So everybody's seeing this question. I'm making sure that everybody's seeing it correctly. Or let's see what is going on here. We have a matrix. So we're going into matrices land, right? So we have a matrix A is given as, and we have this matrix here with all the nice looking elements in the matrix. They're asking us to find, right, the modulus of A, which is the same as saying the determinant of A, right? So how do we find this? How do we go about finding the determinant of a matrix, right? This is a 3x3 matrix, by the way. So, and this is what they're going to test in the exam. For sure, I can tell you they're going to test determinants of 3x3. How do we do this? Okay. With regards to we're just going to run through it really quickly. With regards to the determinant of a 3x3 matrix, what is of main concern to us is the first row, right? The first row of elements. What we need to do is find the cofactor for each one of these elements here, right? And well, take the element and multiply it by its cofactor and find the sum of all those. And that would give you a determinant. Very simple, right? So what I am saying here is this. Let's get into it. So the determinant, right, is given by that. So let's look at first things first. The first element, this 2 here. Let's look at finding the cofactor for it and taking the 2 and multiplying it by the cofactor, right? So let's look at that. This is what you get here. But so it will be 2, right? And to get the cofactor, what we do is we use the cover-up method. We cover, right, the elements to which the 2, right, or we cover up the row and column, right? All the elements in the row and column of that element, right? And what you see we remain with is this nice 2x2 matrix. And what you do with that 2x2 matrix, you see this is the same thing here. You would find the determinant of that 2x2 matrix. And we should know from CSEC days how to find the determinant of a 2x2 matrix. That determinant there would give us the cofactor, right? And you just take the cofactor when you find the determinant of that 2x2 matrix and multiply it by 2 here, right? So that's basically what you're doing. And then we do the same thing for this element here. So let's go and we're doing it. We're just taking our time to just make sure everybody understands this. But this is different. This one a little bit different. But so we cover up the elements in the row and column of this element, right? So, right, cover it up, and the elements remaining are these. That would form your 2x2 matrix. Watch it, look at it very carefully, right? And you find the determinant of this nice 2x2 matrix. From CSEC days, we know how to do this. The only thing is, yes, you have your element here. Your element is 1. You're multiplying your element by the determinant here of this 2x2 matrix. But you have to remember that you need to change the sign of the element. That is very key. You forget that, your answer will be wrong. So be mindful of that, right? And then lastly, what we do in here is we take any -1 and multiplying it by the cofactor for that, right? And how we find that? We cover up all the elements, right, in the row and column of -1, right? So that would leave us back with this here. And look at it. Let's look at it really quickly and see what we get here. -1 by this here. So you could see it clearly, right? This here is the same as this here, right? So that is the same, that is your 2x2 matrix. So that's how we get in that. And when we find the determinant of this 2x2 matrix that we got using the cover-up method, right? We multiply it, right? Or you find the determinant, that would give you the cofactor for this element, right? And you just multiply it by the element itself. And that's basically it, right? So let's get into it. Let's find the determinants of these, and really that's all we need to do. Find the determinants and let's multiply it out. I think hopefully everybody's understanding what I'm saying, right? And everybody's seeing clearly. So the next thing we do is find the determinant, right? We know how we find the determinant. I think Aaron indicated it here in the chat. He said AD minus BC. That's how we did it in CSEC days, right? In O-level maths. So that's what we do. 4 by 0 is 0, and then 6 by 3, right, is 18. But you have to remember to this minus that, right? So that's basically what we get. Then the next one, this is what we have. But remember, be careful with your brackets and your negative signs, right? So that's something else I would want to point out. Be careful with your brackets and negative sign. 0 by 0 is 0. So that's what we get here. But you have to remember, right? It's minus your -1 by 3, which is -3. So just be mindful of that. Be careful, guys, with your signs here. Things could get really messy if you don't be careful with your signs. So be careful with your signs. So then the next thing we're doing is I'm leaving everything as is there, right? This is what we're doing next. And again, be careful with your signs here, guys. 0 by 6 is 0 here. And you have a negative sign, and -1 by 4 would give you a -4 there, right? So you see how careful I am here? Because I want to get my marks. I don't want to throw away my marks, right? So let's go again, right? Now let's work. If you work out this here, you would get -36, right? If we work out this here, this would be +3, but +3 by -1. So that's how we get -3 there. Then here you would get +4 by -1. And that's how you get -4. And in the end, we get our determinant to be -43. Why is in the chat if everybody okay with that determinant? Check it over. If you have your calculators nearby, make sure everything looking good. The calculations is okay, right? But if not, if you have any questions, feel free to send it in the chat. Let me know, right? If not, we move on swiftly. We move on swiftly into the dance, right? Because we have a few more little questions to do, right? So Justin is saying he's okay, right? So let's go on to the next part of this question, right? Let's look at this. So they're saying hence or otherwise find A inverse, right? Or find A inverse, the inverse of A, right? So this is our next thing, the love, CXC love to ask this with regards to our 3x3 matrix, right? They love to ask this question with regards to finding the inverse of a 3x3 matrix. So let's get into it. What should come to your mind immediately? The determinant, or rather, the inverse of a 3x3 matrix is found by taking 1 on the determinant by the matrix of cofactors transposed. That is very key, right? So they say hence. The reason why they say hence, what they say, whenever they say hence in a question, they mean using the result from the previous part, right? So when they say hence here, they mean using the determinant from the previous part. So that is what we're going to do here. We're going to use the determinant from part 1, right? And so this is what it looks like in terms of the formula for the inverse. 1 on the determinant by the matrix of cofactors transpose. This, you're supposed to learn it. Learn it, guys. Know it. Learn it. Know it. Learn it. That's all, right? So how do we find this? How do we find this? We have this part here. We have the determinant already. But how do we find the matrix of cofactors? So we could write it down. The determinant we know is -1.5, -43, right? But how do we find this matrix of cofactors? Is it -43 or was it +43? Let me just check it back really quickly. Right? Yeah, it was -43. I just wanted to make sure. Right? So we're looking at, right. So we need to find out what is this matrix of cofactors, and then we need to transpose it. That is key. Right? So how do we do this? The matrix of cofactors. So let's write down the matrix A. Let's do that. That's the first thing we need to do. So there's the matrix A that we had from the previous part, right? So the matrix of cofactors, remember what we was doing when we found the determinant? We need to find, in this case, we need to find all those small, we need to use the cover-up method, right? So we need to cover up this and this. And this matrix, or this small 2 by 2 matrix that we have here, we need to find the determinant of that, and that will be a first element in your matrix of cofactors. And what we need to do is do that for every element. Cover up your 1. This will be in your matrix here. That's 0, -1, 3, and 0. That would be a new, or that would be the cofactor matrix, or the cofactor for your 1 here. And that is what you would plug in there, right? Let me actually do it and show you all exactly what it is I'm speaking about, right? So the matrix of cofactors will be this, right? Let's look at the first elements, and we're just going through this slowly, making sure that everybody understands it, right? So let's look at the first element, 2, right? And I think we actually already found the cofactors for 2, 1, and -1. We already found it when we found the determinant, right? But let's just run through it really quickly, and this is what you would have. This is a cofactor here. What you cover up, right? This is this. This is the same as this, right? You see in that there? Now let's look at the next cofactor here. The cofactor for 1, right? That will be this here, you cover up, right? So these are the remaining. So that is why this is this. But the key thing is to remember to put this -1. That -1 there is very vital, right? The key thing with this matrix of cofactors is to remember that the signs will be changing continuously, right? For each one of the cofactors, right? What I'm saying is this, right? And you will see it as a progress. So let's look at the cofactor for -1 now. So let's cover up again, right? This is your matrix you're looking at. So that is what I need to put down here, right? So this was the matrix, right? Or the cofactor, right? And we need to find that the determinant of that, and the determinant of that would be the cofactor, right? So you have this now. Cool. Now we have to go on to 0, right? We have to find that. So 0 would be this, this. So the matrix, the 2 by 2 should be this with this. So let's see what I have here, right? And you have to remember to change your sign. So this one was positive. This we change the sign. This was positive, right? So this one was negative. So it's an alternating of the signs. So that is something that you have to be mindful of as well, right? So let's look at the next element. 4 is what we on now, right? So you cover up, and what you're seeing remaining, the 2, -1, -1, and 0. That's what is remaining. So that's what I would have here, right? And so on. You would cover up this, and that's what you get. I hope everybody catching the picture of it. Yeah, you have to change the signs, right? That changing of the sign is very important, Justin. Yeah, it's Pure Maths, Kyle. This is Pure Maths Unit 2. Do not stress yourself, right? Do not stress yourself. So now let's look at the, right? I'm just going to put down the rest of cofactors, right? Or the matrices that we have to find the determinant for, right? So this would be that. And notice the sign change, or the negative sign change, right? So this one, as Justin was saying, positive, negative. What's the sign? Let's just look at the sign. Positive, negative. Positive, negative. Positive, negative. Positive, negative. And then positive again. So be mindful of that positive, negative sign change, because a lot of people just forget it, and you could end up losing a lot of marks just for forgetting that, right? So be mindful of that, right? You could just check this back, make sure you are getting, right, those corresponding cofactor, those cofactor elements there, right? Or the 2 by 2 matrices, right, for which you're going to find the determinant for, and then those determinants would represent the cofactors for each one of these elements here, right? And they would form the cofactor matrix, right? So let's look at it here, right? Fine, this is what you would get here. I think everybody should. Somebody is saying Bro, please clear my doubt. And I'm not too sure what question you're asking there, Danish. Right? So this is what we should get here when we find the determinants of each one of these here. Right? Find the determinant of each one of these. And this is your nice matrix. This is what we should end up with. Right? Your cofactor matrix should be this. Right? If anybody's seen any issues with it, feel free to let me know. Right? Any little whilst you're working it out, or if you're working it out, feel free to let me know, or drop a comment in the live, in the live, or even when it's finished. Feel free to let me know what you don't really understand, Rhonda. Which part, Rhonda, and just to make sure that, just to let you know, this is unit 2 pure maths, right? Just to make sure, right? That you're in the correct class, or you're looking at the correct class, right? This is unit 2 pure maths, right? So you need to specify exactly what it is you have an issue with, right? So this is what we have here. This is a matrix of cofactors here, but remember, we have to transpose it. That is very key. So to transpose the matrix, your rows change the columns, right? So your rows here will change the columns. So you have to kind of transpose it. Well, basically, say rows change the columns, and that's basically what you do, right? Yeah, Justin, I like what you're saying. I love it. I think it's because of how long this process is. The ending parts. Which ending part? This part here, Rhonda. You may have to go back through the video. But I was just trying to explain how you get the cofactor matrices, right? And then obviously you find the determinant of those cofactor matrices to get the actual cofactor itself, right? So let's transpose it, right? When you transpose this matrix, this is what you would have here, right? So this is the transpose of this row here. It changed the column, right? So you'll see in that there. And then we're going to transpose this row here. And this is what you get here as a column, right? And then the next thing, transpose this here, right? And you should change that into a column as well. So this is what you have here. And that's it there, right? You can leave this here under. If you're writing C-sec, this is CAPE. This is a CAPE class, not C-sec maths. So if you're doing C-sec maths, you're in the wrong place. Sorry, unfortunately, right? And you will be very much confused, right? So just feel free to just click like on the video and, before you leave. But yeah, I hope I didn't confuse you too much. But let's move on. This is basically an answer here in the end, guys. I hope everybody following, understanding so far, right? If not, you can always go back to the video. The video will be uploaded. Have no fear. That's it. You don't necessarily have to multiply this by each one of the elements. The negative one on 43, you don't have to do it. You could leave it like this. This is cool, right? If you want to do it, that's not a problem as well, right? But this is your solution here at the end. You're good to go there, right? So what do we do next? Right. So yeah, if all you're writing C-sec, right, and not CAPE, feel free to bust out, This is for the CAPE people who doing CAPE, Pure Maths Unit 2, to be exact, right? So let's move on to the next question. We have some probability here looking like, 2 fair coins and 1 fair die are tossed at the same time. Calculate the probability, or rather, I'm rushing things. Calculate the number of outcomes in the sample space, right? So the matrices question done. We're looking at, it look like probability. No. Yeah, this kind of in the realm of probability. 2 fair coins, they have 2 fair coins and 1 fair die are tossed, right, at the same time. Calculate the number of outcomes in the sample space. So they want to find the number of outcomes in the sample space. So right? So this is what we have here. Right? So 2 fair coins, 1 fair die are tossed, right? So what we need to do here is basically the 2 fair coin, we have to try to figure out what is the sample space that we'll get for just tossing 2 fair coins. So this is how I'm thinking about it. If you toss the 2 fair coins, what we could have happening is we could get a head and a head, right? So this is what we could have happening, right? If you look at the sample space for the 2 fair coins, right? We could get a head and a head. That's the first thing we could get, right? Both could lie on a head. Then we could get one of the coins lie on a head and then one lie on a tail. And then we have, right? We could get 2 of them lying on tails. But then we could also get 1 line on a tail and then 1 line on a head. And that would complete it, right? That would be a sample space there. You could think about any possibilities, but this would be, right? This would be it. That's where it would stop up to, right? Now we need to look at the outcomes for when the die is thrown, right? Or tossed, right? So the die, the fair die would be 1, 2, 3, 4, 5, 6. We know this, right? That is the number of, that is the possible outcomes you could get from the die. If it's a fair die, right? It has all the numbers 1 to 6. So these are the 2 outcomes. Just looking at it separately, the two combine everything together. Look at this. This is really cool here. We could put the fair die and then the 2 coins, the outcomes, side by side, and then watch what we could have happening here. This is really cool here, right? We could have this happening here. Oops. I'm gonna go back. This is what we could have happening here, right? So look at it, digest it a little bit. Watch, this is the outcomes we have here for the fair die, right? Fair die and the outcomes 1 to 6. Then this is the 2 fair coins, right? Remember these outcomes here? That is these outcomes here. And then what we're doing is basically combining your head and your head with 1. That's what you get here, right? Your head and your head with 2. That's our next outcome, right? And we just basically combining the outcomes there. And this would actually give us the whole sample space here, right? That's a neat way of getting the entire sample space, right? So there's a whole sample space. And if you look at it, clearly you could see this is 4 outcomes by 6 outcomes. And 4 by 6 is 24. So your total number of outcomes, right, in the sample space when we toss 2 fair die and 2 fair die, 2 fair coins and 1 fair die would be 4 by 6, right? So that would be answer. Number of outcomes, right, in the sample space would be 4 by 6, which is 24, right? I hope everybody understood that one there, right? But this, you see this here, this little table here, that if you could draw up that, right, it's pretty neat, and it actually helps for the question that to come, right? So let's look at it here. I hope everybody understand that. If anybody have any questions, I hope everybody's seeing it properly too. This one, it's kind of small, but I'll blow it up a little bit on the next question, right? So let's look at the next part, right? So 24 outcomes, right? Or 24, outcomes in the sample space. So let's look at the next part here now, right? Then they're asking, find the probability of obtaining exactly 1 head, right? Probability of obtaining exactly 1 head. So what we could do here, the probability of obtaining exactly 1 head is what I want us to find. But what I would like to do is use the table that we got from the previous question, or that I would have created from the previous question, right? Because if they want the probability that of obtaining exactly 1 head, that would be this row here, right? If we look at it, exactly 1 head, right? 1 head is thrown here, 1 head is, right, obtained here. So it's actually all the elements in here and all the elements we get here, or all the outcomes in those 2 rows there, So you have actually here 6 plus 6, which is 12. So that, remember, probability as well is the number of favorable outcomes over the total number of possible outcomes, right? So the total number of possible outcomes was 24, right? That's the number of outcomes within the sample space. And you put that in the denominator, and on the numerator, you put 12, because these would be the outcomes where you have only one head, or exactly one head being obtained. So this would be a solution here, 12 on 24, or a half, right? So that's basically it. I hope this clears things up, right? And this table here makes things so easy to see in terms of the probability that you're applying here. You could just look at it and pick it out and just put it into the formula for probability, and that's it. So that is your solution for that part. Let's move on to the next part, right? Then they're saying calculate the probability of obtaining at least one head on the coins and an even number on the die on a particular attempt. And again, we could use the table again and just pull out all we need and put it in the formula for probability, right? These type of questions really nice, right? If you drop the table and you have all the outcomes, it's just a matter of pulling it out. So this is what we do, right? We put back the table, right, that would have been created, and yeah, we just pull out what we need. At least one head. Let's go to at least one head. And it needs to be even as well. So at least one head would be one or more, right? So it could be one or two head, right? So you would be looking at actually this portion up here. You wouldn't be looking at this row at all, for sure, right? So you're just looking at this portion up here. But you need to look at the even figures. So it would actually be this here, and this here, these three rows here. Because even, it needs to be at least one head and even. So you could clearly see at least one head and even, at least one head and even, at least one head and even there. Same thing here, 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 and here, and here, and here. Check it out, right? And you would see it. So you could see clearly there is 9 outcomes there, right? You take those 9 outcomes and divide it by 24, and that's your solution there for this question. Simple, simple. If you drop this table, right, it actually makes it real easy. Or some people could actually see it in their minds and actually write it down. But this, it basically, you have all the outcomes written down. So it make it so easy, right? So then we just put on the answer, 9 on 24, and reduce it, you get 3 on 8. And that's a probability there that of obtaining at least one head on the coins and an even number on the die, right, on a particular attempt. And that's a solution there, right? So I hope everybody understanding so far. I hope everybody here with me still, right? The vibe's nice. So let's continue the vibes, right? So we're looking at that is probability. What do we have next? So I think this is the last few questions or the last few parts, right? What do we have here? Determine whether y is equal to c1x plus c2x squared is a solution to the differential equation. And this is the differential equation where c1 and c2 are constants. This is an interesting question. The reason why I say it's interesting is because the way in which they bring the question. Normally, they would ask, or they would say, find the general solution for the differential equation. That's what they normally do. But in this question, they say determine whether the solution, so they gave you the solution, right, of the differential equation. They say this is the solution. You see this y, right, is equal to c1x plus c2x squared. That is the solution to the differential equation. And what is the differential equation? This is the differential equation. So they want us to show or determine, right, whether it is a solution, whether this is a solution. So how do we go about doing that? That's the question, right? The first thing I would do is actually write down the solution. Then the second thing I actually would do is find the derivative, the first derivative of the solution. So that it would be this. right? The derivative of this, right, is C1. So that's how you get C1 there. And the derivative of this is 2C2x, right? And that's it. That is your first derivative. Now let's look at the second derivative. Because if you watch it here, this is a second order differential equation. That is something to, right? It's right second derivative there. So it's a second order differential equation. So let's find the second derivative, right, by differentiating the first derivative. So this is what we have here, right? You just differentiate C1 and that's 0. So that's why I have nothing here for that. And then, well, you just have C2. That's why I have C, right? Or 2 by C2, sorry, right? The differential of this here would be 2 by C2, right? So that's what I have here. And all we need to do now to show that this here is a solution of this differential equation is plug these three equations into the differential equation. If it gives us 0, then we know this is the solution to this differential equation. Everybody understand that? I'm just talking about it right now. So, but if you don't, let's look at it exactly. So what we need to do is substitute these into the differential equation, right? When we substitute it, this is what we will have happening here. Wherever you see y, you substitute what y is. Wherever you see d, wherever you see y prime, you substitute what y prime is. Wherever you see y double prime, you substitute what y double prime is. Watch, look at it here, right? Y double prime, I substituted this. Look at here, right there. Y prime, look at here, and I substitute, right? We substituted that. And then y, right? This here was substituted here, right? I substituted everything, or your y prime, and y double prime, right? Which I gained from the solution that the question gave us of the differential equation, right? And let's see now if when we reduce this up, if it would give us 0. If it would give us 0. If it does, then it is a solution. So let's work it out a little bit. We have to multiply this by this and do a little multiplications and see how things go run. Let me see how it will run here. The first thing, when you multiply it, you will get x squared by c2. You could see that the 2's will cancel off here. And then this one here, what will happen here, boy? Negative x1 by c1 is negative c1x. And then you would get negative x by this, right? So it's this by this, and then this by this, right? And that's how you get these two things here. Right? Clearly, you could see that. Don't forget the x squared there when the x's multiply. Then you just add this here to this whole thing here because nothing multiplying there. So that's what you would have happening here. Right? And let's see who cancels off with who. Right? What we see in here, you have an x squared here. Watch it, this. And you have an x squared here. Right? And then you have negative 2x. You have negative 2c or c2, right? You have 2c subscript 2, right? By x squared. And then you have this, the positive versions, right? The single positive versions there. So this and this will cancel off. You could clearly see that. And then this and this will cancel off. So you get 0, right? Everybody's seeing that, right? So you could see it clear as day, right? This here will cancel off with these two here, and then this will cancel off with this. And because that is the case, you'll get 0, right? So therefore, this is in fact the solution to the differential equation. And this is what you do here. You just state that. Therefore, that is the solution to the differential equation. And that's it, right? You collect your marks and you go up the road. So that's the solution there. I hope you guys understood this one as well, right? I hope it was clear, right? But it's a kind of different question in the sense that normally they ask you to find the solution to the differential equation, right? But in this question, they actually give you the solution to the differential equation and ask you to show that it is in fact the solution. So what you do is you differentiate it, right? As you can see, I differentiated it, right, up to the second derivative, and then use those and plugged it into the differential equation. Once it gave me whatever is on the right hand side of the differential equation, meant, yeah, it's correct and it is in fact a solution. That is it about this question here. I think that's good. I think we went through this one good. Now let's look at, hopefully there's the last question here. Right, so we have show that the general solution of the differential equation, and look at this here, 3 by x squared plus x by dy dx is equal to 2y by 1 plus 2x is, they want us to show this. So they actually, what they do in this question is they gave us the solution and they just want us to show that this is in fact the solution here. So when I look at this, this is our first order differential equation. You just have one, you just have dy dx. You don't have any you don't have the 2y and dx squared. So it's a first order differential equation. How should we solve it? I am thinking solving it using the integrating factor, right? Because in unit 2, that's the method that we're looking at, right? Integrating factor was introduced here. You can also do solve this using the separable variables method as well, but let's use it using the, or let's solve it or find the solution for it using the using what method? The integrating factor method, right? Hi all, guys, don't forget to click like, right, on the video. And yeah, let's continue with this question. So what we need to do is actually rearrange this question, because for first order differential equations, what we need to do, or what we need to make sure is that the function is of the form, or rather the differential equation is of the form dy dx plus py is equal to q, right? And then we need to find the integrating factor, right, which is given by e to the integral of p with respect to dx. And p and q are functions of x only or constants only. That's the things we need to understand and remember, right? And then lastly, to get a general solution. So I just running through how your thinking should be, right? A general solution will be given by y by what? Y multiplied by what? Y by the integrating factor, right, is equal to the integral, right, of q by the integrating factor with respect to dx, right? And that's it. That's what you need to do. So that's your process, right? But let's cut this and actually get into it. Let's get into it. So we're required to show that this here, right, is the solution to the differential equation. Let's show it, right? So what we need to do is we have this here, but we need to rearrange it so that it looks like the form that I was talking about. So that it looks like this form, y plus, or sorry, dy on dx plus what? Py is equal to q. So that's the form we need to try to see how, if we could get it into, right? So what I did here is this. I took this here, sorry, and I sent it over here. I divided it, and then I brought everything on to the left hand side so that you could clearly see this here is my p and my q is actually 0. My dy dx coefficient is 1. So it is of this form, right? This whole thing is my p here, right? My q is 0. So once it's of this form now, we could apply the integrating factor rule, right? So let's look at it here. And this is what we will get here. The integrating factor is given by, right, e to the integral of p, right? P is this entire thing. Just be mindful of that. P is that entire thing. All I did here was actually just take out the negative 2/3 out of the integrating, out of the integral sign, and that's what we get here. But we have to integrate this little fraction here. How do we do that? And there's something you should always be looking forward for or looking towards. what do we do to integrate this? If you look at it carefully, the rule for this integral here is a rule that comes up very often. The integral of this here. This is what you'll get here, which is the ln or the modulus of f of x, right? Plus c. Well, they don't need a plus c in this case, right? But this is what they would have here. So it'll be the integral of f prime on f of x. If you look at it carefully, you would see the differential of x squared plus x is the same as 2x plus 1, and 2x plus 1 is on the numerator. So we could apply this rule for integrating, right? And that's basically what we do next. We just apply that rule. And this is what you will get, right? I should take out this dx. This doesn't need to be there, right? So it's basically just the ln of x squared plus x. That's what you get there. And then lastly, what we have is, and guys, for people who now coming into the live, this is Pure Maths Unit 2 we doing, right? Keep Pure Maths Unit 2, right? Just a reminder. So if you are not doing Keep Pure Maths Unit 2, this will be very foreign to you. You'll be confused, right? So just a quick reminder, right? So as I was saying, we apply the rule f prime on f of x here, right? You'll get ln of f of x. That's what you have here. And then we could use the rules of logs and just bring up the power, right? And what we will get is this here. And you notice that, right, e to the x and ln x are inverses of each other. So they will just cancel off each other, right? All right, cool, ravish, no scene, right? And then you have this in the end here, bam, right? That is what you will be left back with, because e to the x and ln are inverses of each other. So you're just left back with this, right? And as the integrating factor, the last thing to do now is find the general solution, because once you have your general, or once you have your integrating factor, you can find the general solution pretty straightforward. So your general solution is given by this here, right? Y by integrating factor is equal to the integral of, right, your q. Remember, we said this was q, right? Q by the integrating factor, right? So we just replace what is the integrating factor. We know the integrating factor was this, is what we found here, right? So that's where we place it here and here. That's the integrating factor. And work it out. The left-hand side is just the integral of 0, right? The integral of 0 would be a constant when you integrate 0. So you get a constant there. I just rewrote this because this is y by x squared plus x to the negative 2/3. We could just bring that in the denominator, and there's just another way of rewriting that. And then lastly, we just had to make y the subject of the formula. So you take this here, your denominator, and multiply it, right? Because it's dividing on the side, so we multiply on the side, right? Simple stuff. So this is what we get here, right? And then we could just rewrite this because we all know rules of indices. Yeah, so exams coming up. These are exam questions. Hoping that this person doing this is keep pure maths, just to reiterate again, and just rewrite this, right, in the form that they ask us to rewrite it. This is the same as rewriting it like this, right? Because we know, right, if the power on the numerator, right, that's basically your power here, and the power in the denominator is like the root, right? So that's how you get that. So this thing here could just be rewritten in the form that they ask us, right? That they actually ask us to show. And that's basically it, right? So that is that, you know, this is the solution here, and you're good to go there, right? That's the solution there. And I think we have one last question to wrap it up. The live going on for 1 hour and almost 15 minutes. So let's try to finish it here. Right, let me just backtrack really quickly. Right, bam. So there's the next question. I hope everybody's seeing the questions. right? Clearly, we have, this is the last part of it. It's saying, hence, given that y of 0 is equal to 1, solve 3 by x squared plus x dy and dx is equal to, that is basically the same equation that they asked for just now, right? They want us to find a particular solution, right? So to find a particular solution, we need to find the value for c, right? That is key. So this, basically what I want us to do is use this, right? Use the solution. Let me just start over, right? They want us to use the solution that we gained in part 1 to solve this, right? And that is the same solution, right? This is the same differential equation from part 1, right? The solution that we gain, that is the same solution to this differential equation. So let's just look at using this information here that they gave us, find the value for c, and that will be the particular solution, and that is it, right? So let's do that to complete everything. I know this has been a long class or a long session, but let's go. We're almost there. We almost finished, right? So we recall that the general solution is given by this, right? And this is what we're given, right? Let me just write out everything. I'm gonna let everything write out, and this is how we get. And I will explain how we get this in the end, right? So this is the last question. We just explaining this to finish off, guys. So we recall that the general solution that we got in part 1 was this, right? Cool. But the information given in part 2 is that y of 1 is equal to 1. So given that y of 1 is equal to 1, that's what I stated here. Then let's plug in so what it's saying is that this here, y of 1 is equal to 1. What it's saying is that y is 1 when x is 1. So what we do here is just plug in 1 here, plug in 1 here, and plug in 1 here. And then we just solve for c, right? So that is what I did here. And I got c as 1 on the cube root of 4, right? And it's just a matter of now taking the value of c and substituting it into the general solution that we gained, right? And in the end, right, this is what you get multiplied by this. And we just, because everything is under the cube root, we just bring everything, right? Or because everything has been cube rooted, we bring everything under the cube root. And that's how we get this in the end, right? And that is that. That is it. I don't think we have any more questions. No, that's the end of that paper here, 2016 Pure Maths Unit 2. Right, guys, don't forget to like the video, share it, and in the coming weeks, we're just going to look at Module 1 and Module 2, Module 3 questions, right? That's what we're going to do, just focusing on Module 1, 2, and 3. So, yeah, the next few Saturdays, right, leading up to exam supposed to be the 23rd of June, right? It's the 23rd of June, that is Pure Maths Unit 2, right? Yeah, so that is when the time around the time when the exam is. So we just gearing up for exams. We're doing plenty questions. So yeah, just a little reminder, we'll be going live on Saturdays, right, around the same time, right, or in the afternoon time. I just gearing up for the exam. And yeah, that's it for today's live. If anybody have any questions, comments, feel free to do so now, right? If not, the live will be ended. No questions, no comments. Guys, thanks for joining the live. Thanks for being here. Appreciate it, right? And next week we'll do this again, you know, add fun, right? So, love and blessings. We out.